So slope intercept form is one of our most popular ways of doing things. And slope intercept form is y is equal to mx plus b, because we're given the slope and the y-intercept. But this is kind of limiting because the y-intercept is that special point on the y-axis, and that's great. But most of the time, you are not given the y-intercept. You're given a point. So today we're going to learn how to use point slope form. Point slope form. And that kind of relates to what you guys did yesterday for homework. So point slope form is written in this way: y minus y1 is equal to m x minus x1. And this will be one of the more popular ways you'll be writing a line equation from now to calculus. Now again, this kind of looks like similar to point slope form, right? There's still a y, there's still an m, but instead of writing b, we are given an x1 and a y1, x1 and a y1. And this is going to be any point. So this is going to be any point for us. Not just we're restricted to the y-intercept, this could be any point we want to use. Any point we want to use. So the m is still the same, that is still the slope. How much is the graph changing for every rise and run? So this is still the slope, and this is still rise and run. Rise over run. Okay, so let me give you an example of how this is used to write an equation of a line. So if I told you m, the slope is 3, and the point is 3, 2. 3, 2. So I want to make sure you guys label this correctly right now. This is an x1 and y1 value. So just to point out the similarities as our point slope form and our slope intercept form, they both have a y, they both have an x, and these are the same x and y. Again, the only changes is that instead of using a b, I'm not using a b anymore, I'm using a x and y, x1, y1. That's how we're going to call it. So we just plug it in. So y minus y1, now what's y1 over here? It looks like it's a 2, equals to m, which is a 3, x minus 3. Now I want you guys to notice something. When I write stuff in point slope form, it looks like it should be a negative 2, but it really is a positive 2 because the negatives are already in the problem. The negatives are already ingrained in the problem. So I'm plugging in a positive 2. It does become negative 2. Now let me help you see why, so you can memorize this a little better, is that a positive 2 does not cancel out the negative 2 in the front, and doesn't a positive 3 cancel out with a negative 3 in the back? Okay, so in a sense, this value is going to cancel out the value that we wrote. But that's why we need the negative here, and it's going to be super important that we always leave that negative there. So let's rewrite it. Y minus 2 is equal to 3 parentheses x minus 3. Now let's go ahead and simplify this. We want to write this into slope intercept form. Our goal is to get this into slope intercept form. So we want to get this into y equals to mx plus b. So the first thing we're going to do, we're going to go ahead and get rid of the parentheses by distributing it. Let's distribute the parentheses. Y minus 2 is equal to 3 times x is 3x. 3 times 3 is 9. Okay, here's a hint. To get something into slope intercept, you have to make sure y is by itself. Is y by itself yet? Nope, we got one more move. Let's get rid of the 2. Opposite of minus 2 is a plus 2. Y is equal to 3x minus 7. Now we can think of this as a regular graph with a with a slope and y-intercept. Our slope is now 3, and our y-intercept is, oops, wrong letter, Our y-intercept is -7. Now, just to make this fair, is this the same line? Is y minus 2 equals to 3x minus 3 the same line as y equals to 3x minus 7? Well, let's check some characteristics. First, tell me the slope in each of these graphs. The slope for my first problem is still the m value in front of the parentheses. That's a 3. And the m is in front of the x here, so they're both going to be 3. That hasn't changed. How about, would the same points work for both problems? Let's try it. If we said our last point was 3, 2, if we plug in x, we should get out 2. If we plug in x, we should get in 2. Well, let's try it. Y is equal to 3 times 3 minus 7. What's 3 times 3? That becomes 9, and 9 minus 7 is 2, exactly what we wanted. So not only do they have the same slope, but they share the common point. Now, if you wanted to write this using slope-intercept form, you could have. You could have wrote y is equal to let's restart from the beginning. Y is equal to mx plus b, given m is 3, and our point is, we said it was going to be 3, 2. And oftentimes in Algebra 1, this is what you did. You would use the information here and plug it into our slope-intercept form. And that's 100% okay. 2 is equal to 3 plus b. And we don't know what b is. That wasn't given. So 2 is equal to 9 plus b. Get rid of the 9. Opposite of plus 9 is minus 9. B is equal to -7. Y is equal to 3x minus 7. Now, one big thing when we do use a slope-intercept form is that you have to remember to plug in b. You have to remember to plug in b. But in point slope form, if you look here, the answer is automatically given as a line equation. There's no plugging back in. We used the right tool for the job and gave us the answer we wanted. It gave us back our line equation. Okay, so let's do another example of our point slope form. If m is equal to 1/2, and the point is going to be 5, -2, I was given a slope and a point. Given a point and a slope. We're asked to write the equation of the line in slope-intercept form. So we want y equals mx plus b. But we don't know what b is. So I want you guys to practice using point slope form. Y minus y1 is equal to m, x minus x1. This is going to be our big deal. Okay, this is going to be our big deal. We'll be using this. So y minus -2 equals to 1/2 x minus 5. Now this answer is going to be a fraction, which is fine, but let's go ahead and it'll help us practice our fractions. So right here, a negative and negative become a positive. Y plus 2 is equal to, we're going to distribute this parentheses. 1/2 of x is just 1/2 x, and half, write this as on the side, 1/2 times 5 is 5/2. No reducing. So this is minus 5/2. Now, this is something that we have to practice, and we probably haven't done this in a while since Algebra 1, is that we're going to combine the 2 by minusing 2 to both sides. But if you can notice that these guys are not the same. They don't have the same denominator. So we have to change it. So this is what we're going to practice. How do I change something to a common denominator? We're going to multiply it by that denominator, but on top and bottom. Somewhere right on the side, we're going to say it's going to be multiplied by 2 over 2. Why did I choose 2? Because we're going to change the denominator. And when I do this, we end up with negative 4 over 2. Here's my follow-up question, is negative 4 over 2 the same as negative 2? Is negative 4 over 2 the same as negative 2? Well, yeah, I did this so that these two numbers here can now combine super easily. Negative 5 over 2 minus 4 over 2, since they have the same common denominator, we can write it as y is equal to 1/2 x minus 9 over 2.
What did you just do for the, do you like multiply it by
I
something?
multiply it by the common denominator. So I need a 2 on the bottom, but we don't have a 2 on the bottom here. So whenever you want to change something to a fraction, you just multiply the top and bottom by that same fraction number. Let me give you guys an example on the side. If I give you the number 6 over 5, okay, plus 3 over 2. Oh wait, let's not do that one yet. Let's do an easy one. Plus 3. I can't add these together because one is a fraction and one is not. Now, why can't you add these together? Because 5 over 6 isn't really a 5 and a 6. 5 over 6 is really 1.2. How would you know that? Do you really, you're not a human calculator. So 5 over 6 looks bigger than it really is. So to make our lives easier, we're going to, instead of changing 5 over 6 into a decimal number, we're going to change 3 into a fraction because it's actually going to be easier. So let me ask you, what is the denominator I want to change the 3 into? What's the denominator I want to change the 3 into?
5.
Change into 5. So the trick is multiply the numerator and the denominator by that fraction, 5 over 5. What is 5 over 5 anyways? 5 over 5 is just 1. I'm not changing the value. I'm changing the way it looks. This is math plastic surgery. Okay? You might look prettier, but you're still ugly on the inside. So what we do is we say we say 6 over 5, and we end up with 15 over 5, because 3 times 5 is 15, and invisible 1, 1 times 5 is 5. Now, sorry, that's a plus sign. A follow-up question, is 15 divided by 5 the same as 3? Is that just another way of saying 3? It is. I may change. When you go to a liquor store and you give them $1 and they give you back 4 quarters, you're like, is this the same thing? You can try to cheat a little kid. Don't do this, but you can try to cheat a little kid. You say, man, you have $1. What if I trade you for 2 quarters? Isn't 2 bigger than 1? Let's make the trade. And then once he trades it, you say, why don't I give you 4 nickels for your quarter? Because 4 is bigger than 2. And then you just keep ripping him off slowly. But what we're doing is we're not changing the value, we're just changing the way it looks so that we can add the numerators. Again, here's a trick if you didn't catch it. If I'm giving you some ugly, sloppy fraction, I can change the whole number because it's easier to change the whole number. So give them the same fraction. I want a 7, I have to write 7 on top and bottom. 3 plus 28 over 7. Now they have a common denominator. We can now add them together. Okay, give me 1 second.
But,
Sure, let's go do something totally random, okay? Can you guys type some numbers in the chat real quick? Just type some numbers in the chat and we're gonna use those numbers. Y minus y2 equals to mx minus x2. Thank you. Oh, you guys got some crazy numbers in there. Oh my gosh, you guys don't like each other. Oh my goodness. Okay, I see a lot of 5s, I see a lot of 7s, I see a lot of 4s. Okay, m is equal to 4 over 5. And our points will be, oh my goodness, 7, comma, negative 13. All right, thank you. So I took a bunch of weird numbers from your chat, and we're gonna write this into an equation. First, do we have a slope? Yes. Do we have a point? Yes. So we have to use our point slope form. Folks, because we have a point and we have a slope, this is the tool we're gonna use. It's gonna be ugly. I know it. Looks ugly already, but let's do it. So label this x1, y1. You just have to do it for like a week and then you'll know it already. So let's plug it in. Oops, I don't know why you wrote 2 there. That's a 1 there. Those are both 1s. So y minus negative 13. Take a look, I put a parentheses because I want to make sure I don't mess up with that negative negative. Y minus negative 13. Put a parentheses there. We know m is 4 over 5. X minus 7. Okay, y plus 13, because negative times the negative is a positive. Now, here's going to be something crazy. We're going to multiply the fraction in here. That's going to be 4 over 5x. And how do I multiply a by a fraction by a whole number? Remember, you can put a 1 on the bottom. So it's just going to be 28 over 5 minus 28 over 5. That looks ugly. Yeah. Okay, next move is we're going to try to get y alone, just like slope intercept form. I'm going to minus 13 to both sides. So look how I'm going to write this. I'm going to write minus 13 to both sides. Now, I see that negative 28 over 5 doesn't mix with the 13 because of the fraction. So that's spent a little bit of time and changing them so they have a common denominator. What do you guys think that common denominator has to be? 28 or 5? Which one is the denominator? It's the 5. Thank you. So I'm going to write 5 over 5. I'm multiplying the 5 on top and on bottom. So it looks different, but it's still exactly the same value. It's math plastic surgery. 5 times 13 is actually going to be 65 over 5. Now, I want you to see that the denominators are the same now, right? The denominators are the same. So we just have to combine them. Y is equal to 4 over 5x minus 28 and 65 combined to become 80, 93 over 5. It looks ugly, but we just picked any numbers that we wanted.